Hey there, it's Tuesday, May 26th. You had yesterday off for Memorial Day, so we're going to do our week at a glance today. It's Tuesday. Today we're going to review in preparation for the Chapter 10 quiz. You can watch the video today and start the homework. Then tomorrow you can finish the homework and come to office hours. The office hours are a little bit different this week. They're on Tuesday and Wednesday instead of Thursday. So come to office hours back-to-back days, Tuesday and Wednesday. Then you're going to take the quiz on Thursday the 28th. Then on Friday the 29th, you'll watch the 10.6 video and start that homework. But that homework's not due until Monday afternoon, next Monday, June 1st. So we're going to review in preparation for our last quiz ever. And we're going to do this straight from the book. It's always the green page. It's the green page of the last chapter, 10. Here we go. Here's the warm-up. I know this bottom one is cut off a little bit. Give it a try. It says, tell whether the events are independent or dependent. Explain. So it doesn't say to find the probability. It says to say whether they're independent or dependent. Give this warm-up a shot. Pause the video and we will review. So for number 1, it says you roll a number cube twice. The first roll is a 3, the second roll is an odd number. And we really want to ask ourselves, is the second roll dependent upon the results of the first roll? And in this case, the answer is no. The shape of the cube doesn't change. If you roll a 3 in the first one, you can still roll the 3 in the second one. These events are independent. Let's look at number 2. It says you flip a number coin twice. The first flip is heads and the second flip is tails. So again, the first flip is heads. It doesn't mean that you can't flip heads again. So these events are completely independent of each other. The result of the first one does not affect the results of the second. Number 3, you randomly draw a marble from a bag containing 3 red and 5 blue. You keep the marble and then draw a second marble. So for the first roll, for the first draw, you had 8 marbles. For the second draw, you only had 7 marbles. So the second event is dependent upon the results of the first. These events are dependent upon each other. The results of the second are dependent upon the results of the first. Number 4 says you randomly draw a marble from the bag containing 6 red and 2 blue. You put the marble back and then draw a second marble. So for the first draw, there were 8 marbles in the bag. You drew one out and you put it back. So when you drew the second one, there are still 8 marbles in the bag. These events are independent because you put the marble back. Okay, so now I'm going to start that green page. We're going to do some examples, a few of each type that you can expect on the quiz. So here we go. It says you randomly choose one butterfly. Find the number of ways each event can occur. So the number of ways to choose a red is 2 because there are 2 red butterflies. You could even turn that into a probability very easily. The probability of choosing red is 2 out of 1, 2, 3, 4, 5, 6, 7. 2 of 7. What about choosing brown? There are no brown butterflies, so the probability or the number of ways is 0. Choosing not blue. And the question is really asking you, how many butterflies are not blue? So that's 1, 2, 3, 4 butterflies are not blue. And if the question asked about probability, then you would just write 4 over 7. Let's keep going. It says you randomly choose one paperclip from the jar. Find the probability of each event. So for all of these, we'll need to know the total. So you'll have to total these up. So this is 9 and 7 with the 4, so that's 13. 20 paperclips in this jar. So the probability of choosing a green paperclip, well, 6 of them are green and there are 20 in the jar. That's the probability. Now, can you reduce? Absolutely. These are both divisible by 2, so we'll have 3 over 10. Choosing a yellow paperclip. There are 5 yellow paperclips and 20 in the jar. 5 goes into both of those. 5 goes into 5 one time. 5 goes into 24 times. Not choosing a yellow paperclip. That's all the paperclips that are not yellow. If 5 of them are yellow, 15 of them are not yellow. And you can reduce that by 5 as well, 3/4. Now, does it make sense that these add up to one whole? 1/4 and 3/4 is one whole. Absolutely, because there's a 100% chance that you will either draw a yellow or a not yellow. That includes all the paperclips in the jar. Number 7, it says choosing a purple paperclip. There are no purple paperclips, so the probability of choosing a purple paperclip is 0. So this is theoretical probability. You can expect some of these on the quiz. I think there's at least 3. Let's try some experimental. Here's an example of experimental probability. Now, on question types like this on the quiz, I am going to tell you what the total is. So I will tell you what the total is right now. This in this experiment, they rolled that number cube 120 times. And they recorded the results as they rolled that. So it says use the bar graph to find the experimental probability of the event. So in this experiment where someone actually rolled a number cube 120 times, they rolled a 4 16 of the times. So that's right here. 16 of the times. So the probability is 16 out of 120. Now you can reduce that. You can reduce it at least by 2, and we'll have 8 over 60. You could reduce again by 2, which is 4 over 30. Oh my gosh, and we can keep going. 2 over 15. Now, if you use your multiplication chart, I have a feeling some of you will do this, and that's totally fine. You can. It's great. If you have your multiplication chart, you can find the greatest common factor between 16 and 120 and reduce by that number first. Let's look at number 9. Rolling a multiple of 3. There are 2 multiples of 3 in a number cube, 3 and 6. They rolled a 3 21 times, and they rolled a 6 23 times. All together, they rolled a multiple of 3 44 times. And we can reduce that. I can see that we can reduce by 4 right here. 4 goes into 44, and 4 goes into 120. And you can leave it like that. Let's look at number 10. I'm going to show my work down here. It's a little bit cramped. Rolling a 2 or a 3. So they rolled a 2 22 times. They rolled a 3 21 times. That's a total of 43 times out of the 120 they rolled. 43, I think, is prime. Nothing goes into that. You can check your multi-chart on that. If you don't reduce on the test, you'll still get credit. Look, number 11, rolling a number less than 7. All of the numbers on a number cube are less than 7. So the probability of rolling A number less than 7 is 100%, or 1. 1 out of 1, or 120 out of 120. 100% chance that's going to happen. Let's keep going. There are 2 questions on the quiz about fundamental counting principle. You don't need to draw a table or a tree to get this done. You can just use the fundamental counting principle just the way it says to use multiplication. So let's look at number 12. There are 1, 2, 3, 4 options for type of calculator, and there are 3 colors, black, white, and silver. That means that there are 12 options. I just used multiplication. Let's try number 13. For a vacation, there are 1, 2, 3, 4 options for destination, and there are 2 options for length. There are 8 total options, outcomes of vacation choice. Use multiplication. Don't spend time drawing a tree. That's why we have the fundamental counting principle. All right. Last 2 here are about compound events. So let's look at number 14. We've got some pens here off to the side. We have 5 total pens. 2 of them are black, 2 of them are blue, and 1 is red. You randomly choose one of the pens shown. What is the theoretical probability of choosing a black pen? Theoretical means that we're not actually choosing pens. It just means in theory, we're going to hypothesize about the probability. There are 2 black pens in the pile and 5 total. That's it, right? That's the probability. Okay, here comes the compound event. It says you randomly choose one of the 5 pens shown. Your friend randomly chooses one of the remaining pens. That means you kept your pen. What is the probability that you and your friend both chose blue? So this is 2 events occurring. You choosing and then your friend choosing. So we need to find the probability of you choosing, and we're going to multiply it by the probability of your friend choosing. So what's the probability that you're going to draw a blue pen? Well, there are 2 blue pens in the pile and 5 total. But once you draw one of them, you drew this blue pen out, you have it in your pocket now. There are only 4 left, and one of them is blue. So the probability that your friend is going to draw a blue pen is 1 out of the 4 remaining pens. To find the probability of them both occurring, we'll multiply. Of course, you can cross-reduce. 2 and 4. And we'll get 1 out of 10. There's a 1 in 10 chance that you'll both choose blue from the pile. Now this is a tough concept here, multiplying for dependent events. Make sure that you're practicing on homework and extra practice in the textbook, and come to office hours if you don't understand. I want to help you, but I'll never know unless you talk to me, communicate with me. I know it's hard because it's not like we're sitting there together and I can tell when you're not getting it. You have to tell me when you're not getting it. Okay. Good luck on the quiz, and I will see you soon.